Going live on YouTube. And we'll bring up Hangout Meet. Bring up Hangout Meet. We're good.
Okay. We got anybody online?
There are 8 concurrent viewers. 10.
Okay. All right.
And
So
Rachel says hi in the chat.
Okay.
And she can hear us.
Okay, cool. All right. So we normally start this about 5 minutes after time for everybody that's on right now. That's usually just to give people a chance to get to the parking lot and get into the clubhouse. I don't know if there's any kind of lead time we need to give for people on a streaming video platform. Any opinions, Wolf or Glenn?
I'd say start on time.
Start on time. Okay. All right. Well, welcome to the introduction to the Night Sky Talk for May 2020. I'm David Grover. I have Glenn Newell also managing streaming of this talk. I don't think this is the first public streaming we've done, but it's the first one for this talk. So what we're hoping to do is over time is get more of our club programs for the public up on some kind of online distribution system like the one we're trying tonight. That's obviously hard to do if you're trying to get people to look through telescopes or if you're trying to get people to look up at the sky. So bear with us. This is a public talk, and we normally give this first quarter moon, and we give a similar one last quarter moon at the Hoogie Park Clubhouse in San Jose. So this is the introduction of the Night Sky Talk for May 2020. We are going to split this talk into 2 pieces. So the first half of the talk will be about some techniques and some tricks you can use to find your way around the night sky. The second half of the talk will be about some things that you can see, and you'll be able to use those techniques to find these things. It'll make it easier to find these things in the night sky. So if you have questions, you can post them in the YouTube chat window, and Glenn will relay the questions to me. We have a few minutes of delay here, so it's possible that your question may take a while. Normally what we like to do with this is people just shout questions out, but obviously that's going to be a little bit difficult to figure out here. So questions in the pardon me, in the YouTube chat window, and Glenn will relay them to me, and feel free to just ask questions. So this is an informal talk. There's nothing really, you're not going to insult me if you ask something. All right, so finding your way around the night sky. So the first half of the talk is going to be about techniques and some ways of understanding how the night sky works so that you can find your way around. In the northern hemisphere, there are really only 4 big groupings of bright stars and easy to find constellations and asterisms or patterns. And they cover a fair amount of what's in the night sky. So if you kind of get a sense of what these super constellations are, then you have a much easier time of finding your way around the sky. So what we'll talk about first are these 4 super constellations. The first super constellation is the polar vortex. So the polar vortex is Let me see here. So the polar vortex is this collection of bright stars and patterns around Polaris, which is the North Star. Polaris is called the North Star because it appears to sit almost exactly on top of the North Pole. So if you can find Polaris, you can find North generally, or really always. So this Polaris isn't always the North Star. In a few thousand years, 10,000 years or so, it'll have moved off, and there will be a different star over here that'll be the North Star. But for now, Polaris, for the next few thousand years, Polaris is the North Star. So the polar vortex consists of stars and constellations that move around Polaris. That includes the bright star Capella in the constellation Auriga, the really easy to find constellation Cassiopeia, or the Big W, the star Deneb in the constellation Cygnus, the Swan, the bright star Vega in the constellation Lyra, the Lyre, and then the Big Dipper, which is a fairly easy constellation to find. The Big Dipper is one of the easiest in the Northern Hemisphere to find, and most people figure they can find it fairly easily. So if you have a sense of these bright stars in the polar vortex, you can start to find your way around things. So one of the easiest little tricks to learn is to use the pointer stars in the Big Dipper. And so the Big Dipper is this pattern here, right? It looks like a dipper. There's the handle. There's the cup of the Big Dipper. Is to use the Big Dipper to find north. So if you use those two stars at the end of the cup of the Big Dipper and you draw a line through them, the first star that you'll run into is Polaris. This is actually, this distance here between the cup and Polaris is 5 lengths. So 5 lengths of the cup, but it's a really easy pattern to find here. You can use the other side. You can use Cassiopeia as well, the E, to point yourself to Polaris. It's a little bit more of a swerve there, but it's also an easy way to find Polaris. But the 2 pointer stars in Polaris then, in the Big Dipper, allow you to find Polaris fairly easily. We can also use the handle of the Big Dipper to find the star Arcturus. Arcturus is a very bright red star that you'll see in rising in the east, just a little ways over the horizon now. Well, quite a ways over the horizon, but it's just on the horizon now in San Jose, fairly easy to find. But Arcturus is easy to find because of this arc in the handle of the Big Dipper here. So amateur astronomers use a phrase to find Arcturus. They say arc to Arcturus. And normally, at this point, I'm going to ask for some kind of audience participation. So what I want you guys to do at home is repeat after me. And I can't hear you, so I want you to repeat after me. Arc to Arcturus. Arc to Arcturus. Arc to Arcturus. And from there, we can spike on to Spica. So everybody just give me an indication in the chat that you've done, that you've repeated after me anyways. So we can also use the Big Dipper if we draw a line through the opposite side of the cup. That gets us to the star Regulus in the constellation Leo. From Vega to Deneb gets us to the big square, as well as the other side of Cassiopeia. So the big square is a big, fairly easy constellation to find as well in the polar vortex, the constellation Pegasus. So why is this called the polar vortex? Well, from San Jose, pretty much any component of this circle is going to be visible at any one time of the year, or all of this is visible at any one time of the year. Some parts of it are going to be to the south. So when Auriga is high up in the sky, Vega will be low on the horizon. When the Big Dipper is high up in the sky, Cassiopeia will be low down on the horizon. Cassiopeia is the W here, right? So at any point in over the course of the year in San Jose, any of this stuff will be visible. Now, as you go further north, as you go past, say, Northern California, Oregon, Seattle, further north than that even, Polaris climbs up higher into the sky. And all the other stars that are around here and the constellations around here also climb up higher in the sky. Until you're at the North Pole when Polaris is directly at the very top. Where we're at, 37 degrees up, Polaris is about 37 degrees up from the horizon. That gives us a vision of all of this stuff, a review of all this stuff. So any questions about the polar vortex?
We had some arc to Arcturuses in the chat.
Okay, excellent.
And Jim wants to know, will this video be available on YouTube later? Yes, it will.
Okay, cool, excellent. Like to hear that. You need to do the repetition piece, otherwise you won't remember it. And a good portion of this is just going to be remembering these techniques. So the next big super constellation is the Summer Triangle. And the Summer Triangle is starting to rise now. It'll be more visible, obviously, over the course of the summer. It really hits the high, really, in San Jose, it's just to the south of us, high up in the sky, passes straight overhead. It's a very bright constellation, lots of cool stuff to see. So the Summer Triangle is composed of 3 of the brighter stars in the Northern Hemisphere, not the brightest, but they're very easy to pick out. So Vega, which we mentioned earlier, is part of the polar vortex, and Deneb, also part of the polar vortex. Vega's in Lyra again, Deneb is in Cygnus the Swan, and Altair is in Aquila the Eagle. So it's called the Summer Triangle because it's a triangle, obviously, but there are some really easy things to spot in the Summer Triangle here. So one of them is Deneb here in Cygnus is the tail of the swan. So Cygnus is a swan. You can see the wings there kind of stretched out. There's the neck of the swan there, and then Deneb is in the tail. This pattern, this core part of the constellation here is called the Northern Cross, and it's fairly easy to spot. This fuzzy stuff here is the Milky Way. So the Summer Triangle sits on top of the Milky Way, where we see through it to the Milky Way. So there's a lot of interesting stuff in here. From Deneb to Altair gets us to Sagittarius down here in the center of the galaxy. From Vega to Altair gets us to Fomalhaut and Aquarius and Capricorn, the fainter constellations of the zodiac. From Vega to Deneb gets us up to Cassiopeia, again in the vortex. And from Deneb to Vega is an alternate way to Arcturus. So a couple other patterns here to keep in mind. One is Deneb to Vega gets us to Arcturus, but it passes through this shape over here. This particular shape in the core of the constellation Hercules is called the keystone. And it's also a really easy pattern to spot. It's called the keystone because it appears to be the keystone in the arch of the sky. So in the arch, the architecture of the arch, the keystone is the piece that holds the arch together. This appears to be a keystone at the top of the sky. So a fairly easy pattern to spot. You see the big square over here, right? So there's Cassiopeia, there's the big square. The big square is a pretty easy one to spot. 2 really important ones, especially coming up through the summer. So Sagittarius is this shape down here. Sagittarius is in the center of the galaxy. This shape is called the teapot. That's the core of the Sagittarius constellation. And it's called the teapot because it looks like a teapot. So here's the body of the teapot. Here's the spout. Here's the lid of the teapot. There's the handle, right? And so the teapot's the easiest part of Sagittarius to spot. Fairly, it'll start showing up probably in a month or 2 on the southeastern horizon. It'll rise fairly high up in the sky to the south over the course of the summer. Out of the spout of the teapot is what amateur astronomers or astronomers call the steam. So there's a whole series of globular clusters and nebulae and really cool stuff in through here. This part of this hazy patch is the center of the galaxy. So this is our downtown portion of the galaxy. If you think of a galaxy as like a giant city, right? This is the exciting downtown San Jose right here. Is Sagittarius. So There's black holes, there's globular clusters, right? There's giant nebula, all kinds of really interesting stuff to see. This constellation here is Scorpius. Scorpius is a fairly easy constellation to spot because of the shape itself, right? So it kind of looks like a scorpion. There's a bright red star at the head of the scorpion called Antares, which means the anti-Mars, but it's really easy to spot. It looks like a jewel on a lot of sort of late summer evenings. So the scorpion here is, this shape was picked, or this was named by the Greeks, the scorpion. But in the movie Moana, this is Maui's hook. In Polynesian astronomy, so Polynesian astronomy, Polynesians used the summer triangle, called the summer triangle the navigator's triangle, because they used it to navigate around the Pacific. And one of the tricks they used to navigate around the Pacific, or techniques they used to navigate around the Pacific, was to use constellations. This constellation points to the south historically in Polynesian astronomy, and so it became, and it's also just known as Maui's hook. So in the movie Moana, this shape is, in Polynesian astronomy, not just the movie Moana. In Polynesian astronomy, this is Maui's hook. So if there are any 8-year-olds in the audience, that's something to keep in mind. So one cool thing about the summer triangle from the standpoint of Polynesian astronomy, so for the Polynesians, the navigator's triangle was a map of the Pacific. Deneb was Hawaii, Vega was Easter Island, and Altair was New Zealand. And the stars in the inside of the triangle were associated with other islands in the Pacific in a kind of a mnemonic pattern. So they don't necessarily have exactly the same distances. The distances aren't to scale, but the order of the stars within the summer triangle, within the navigator's triangle, were associated with particular islands in the Pacific. So some Polynesian navigators were able to use the navigator's triangle as a kind of a map that they could use to find their way around the Pacific. Any questions on the navigator and the summer triangle? Okay. The winter hexagon. So the winter hexagon is setting now. It's got the brightest stars in the northern sky, and a lot of really cool stuff in it. The winter hexagon is Sirius, which is the brightest star in the northern sky, Procyon in Canis Minor, Castor and Pollux in the constellation Gemini, the twins, Capella in the constellation Auriga, Aldebaran, which is in Taurus, the bull, and then Rigel, which is in the left foot of Orion. So Orion is really easy to spot. Orion, the 3 stars in Orion's belt are next to the Big Dipper, one of the easier patterns in the sky to spot, right? Betelgeuse is a very red star in Orion's right shoulder. Rigel is a very red star in Orion's left foot. From Rigel to Aldebaran gets you to Perseus and Cassiopeia. From Sirius to Procyon gets you up to Ursa Major, and then to the Big Dipper. And then from Capella through to Cancer, through to Castor and Pollux gets you to Regulus again. So Regulus is the brightest star in the constellation Leo, the lion. Leo looks like a lion in this rendering, right? So here's the lion, there's the body, there's his foot, there's the mane. I think that this backwards question mark is one of the easier patterns in the sky to spot. So, so if you can spot the backwards question mark, then you're looking at Leo. So a couple of easy patterns then to keep in mind. So let's go back here. So we have the Big Dipper. We have the Big Dipper, which is very easy to spot, right? We have Cassiopeia, which is this W, which is very easy to spot. We have the Northern Cross. We have Sagittarius, the teapot. We have Maui's hook in the scorpion. And then we have Orion's belt and the backwards question mark. So some easy ways to find your way around. Some easy ways to sort of to divide the sky up. So the final super constellation is the skylight. And the skylight is not really an organization so much as it is kind of an absence of organization. So because of where we're at in the Milky Way galaxy, there are parts of the year when our view in the rest of the universe, our view out to the rest of the universe, is blocked by light pollution from our galaxy. So light pollution from our galaxy is it's horrible. There's not a lot we can do. We've called the central black hole, and they are trying, they're trying to think of policy. But in practical terms, what's happening here is that the arms of the galaxy in the summer and the winter sit right on top of us, and so it's much more difficult to see outside of the galaxy. At other times of the year, specifically in the spring and the fall, the arms of the galaxy are on the horizon, and we can see out the top of the galaxy into the rest of the universe. And so that, I call this the skylight, because effectively we've got the two ends of the house here, and we can see out the top into the rest of the galaxy. So, so within this space, there are a lot of familiar constellations, right? So we have Ursa Major, we have Procyon. You can see here the right. So the winter hexagon is over here. The summer triangle is over here, right? The polar vortex is over here. This whole area in here is the skylight. There's Arcturus, which we can get to by arcing, right? So this whole area in here is all the rest of the universe, and each of these dots is a reasonably easy to find galaxy. So when we're in this skylight period of the year, we can see all these other galaxies out to, with a reasonably decent telescope, out to like 80 million light years away. So, so we have a much better view in that time of the year. All right, any questions about the super constellations? Okay, cool. So since you go outside, right, you have a reasonably good idea how to divide the sky up into super constellations. Now it's time to get yourself a star chart. A star chart can help you find the objects that you're interested in. So whether that's galaxies or planets or whatever, the star chart's going to allow you to translate what you're seeing on the star chart into the sky to help you figure out what's going on. It's a map of the sky. Obviously, the problem is that the problem we have as astronomers is the sky doesn't come in a grid. So it's difficult to know precisely how to translate the relative scale of the grid and the star chart up into the sky. These hand signals, which are ancient, right? So these hand signals go back thousands of years. They're used in the South Pacific, they're used in the Sahara, they're used in the Great Plains, they're used in the Arctic. They're just everywhere. These are the hand signals. These hand signals are how you translate the space on the map to the space in the sky. So this is another audience participation thing. I want everybody to stand up. And I'm going to see if I can do this here without shutting everything down. All right, so you should be able to see me. Okay, so stand up, and I want you to put your arm out as far as it goes. So this works whether you're small or you're big. If you're small, your hand's not very big, but you can't stretch your arm out as far as it goes. And if you're taller and larger, then your hand will stretch out further, but your hand is smaller. So you want to stretch your arm out as far as it goes. You put up your little finger, that's 1 degree. You put up 3 fingers, that's 5 degrees. You put up your fist, that's 10 degrees. You make the rock on sign, that's 15 degrees. right? So rock on, that's 15 degrees. And then 25 degrees is the surfer sign. So what that means is, if we go back to
And there's a question.
okay, go ahead.
Rachel wants to know, what's the clearest ability of seeing a super constellation with binoculars?
Oh, the super constellation doesn't take any binoculars at all. You should be able to see that just by going outside. So on a reasonably clear night, and I don't think tonight's a reasonably clear night, but on a reasonably clear night, the like the polar vortex will be just right out there in the sky to the north of us, right? So you'll be able to see the Big Dipper. You'll be able to see Cassiopeia, for example. All that stuff will be out there. Same with Orion. If you look outside now, in about an hour, Orion will be on the eastern or on the western horizon. You'll see the 3 bright stars in Orion's belt. You'll be able to pick out the winter hexagon fairly easily. So you won't need any binoculars for super constellations. So if we go back to the star chart, if we know that there's a cool, oh wait, where's my laser pointer here? So if we know there's a cool couple of galaxies sitting over here, and the grid tells us they're about 10 degrees from Dubhe, then what we do is we go up, we find the Big Dipper. This is the Big Dipper here, right? So there's the handle that we arc to. Arcturus is going to be over in the corner here someplace, right off to the edge. There's the Big Dipper. There's Polaris over here somewhere. But if we know that there's 2 cool galaxies over here about 10 degrees off of Dubhe, we're going to go out, find the Big Dipper, the cup of the Big Dipper, and put our fist, right? So that it's right on the edge, right? There's our fist, put it right on the edge of Dubhe, and then we'll be able to start looking with our binoculars over here about 10 degrees away. Does that make sense?
Do you want to flop your display back so the slide is bigger?
Sure. Let's figure out how I...
It's just display settings, I think. There. So swap.
Okay, there we go. How's that?
It didn't really change anything. Oh, here it comes. Nope, now there's nothing.
Okay. How's that?
Nothing yet.
All right. How are we doing?
Just not seeing any presentation right now.
Okay, 1 sec here. Let me reset the...
See the PowerPoint application now.
Okay.
There we go.
Okay. All right. How's that?
Yeah, that's good. Thanks.
Okay, cool. All right, so what can you see? Well, on a good night, you can see thousands of stars. We measure the brightness of star in terms of using a term called magnitude. And magnitude has a complicated logarithmic relationship. And if you're curious how it works, I would suggest you take a look at Wikipedia, because it's an old and somewhat arbitrary explanation. But for our purposes, the lower the magnitude, the brighter the object. The higher the magnitude, the dimmer the object. On our planet, the brightest object is the sun, with a magnitude -26. Full moon is magnitude -12. Venus is -4. Jupiter is often -3. Sirius, the brightest star in the sky, is -1. And then As we get dimmer and dimmer, we get more and more objects that are visible. So most of the time in San Jose, you can see to about magnitude 3 or 4. That's the limiting magnitude. The human eye can usually see to about 6 or 6.5 on a cloudy, on a clear night, if the person's vision is good. In this range, though, there's a whole variety of things. So it's not just stars that we're looking at. We're also looking at various kinds of planets. We're looking at galaxies. We're looking at globular clusters, nebula, and a whole variety of things. Once you start to add in instruments, so binoculars can get you to magnitude 7 or 8 on a really good night. Telescopes will get you regularly to magnitude 9 in San Jose, 10 if you get outside the city. That gets you up to 340,000 objects. That's a lot of different kinds of things to see. Most of the time, again, in San Jose, with your own eyes, you'll get to magnitude 3 or 4, depending on how dark the sky is. And that's, again, a light pollution issue. So you can use this chart. This is a service put out by Environment Canada called Clear Dark Sky. This allows you to determine how the seeing is going to be in any given night. So the limiting magnitude is a function of a whole bunch of different kinds of considerations. The limiting magnitude, remember, is the dimmest object you can see with your own eyes in say the city of San Jose. And the limiting magnitude is dependent on the amount of water vapor in the atmosphere. Obviously, if there's lots of clouds, your limiting magnitude is going to be really high or really low. The moon can have a big impact on limiting magnitude, light pollution, heat, wind, etc., all sorts of stuff. Obviously, if there's smoke in the sky from fires, that'll have an impact. So what I generally do with this clear dark, so this is called the clear dark sky chart. So I look at cloud cover, I look at transparency, and I look at seeing. So darkness is going to tell you roughly when the sun sets, right? So there the sun's setting a little bit after 2100 hours. This is the darkest part of the day. The darker the blue here, the better the seeing. So these are 4 out of 5s from a cloud cover standpoint. These are 3 out of 5s and 2 out of 5s in the transparency and the seeing. So tonight is not a great time to pull a telescope out. That doesn't mean that there's nothing to see, because the cloud cover is actually fairly good based on this forecast tonight, right? It's just that your transparency and seeing aren't going to be very good. So for lots of things, so for the objects that we're going to talk about a little later, tonight's not the best night to look at stuff, but there is, for example, the moon is up. There's nothing about this transparency and seeing forecast that would stop you from looking at the moon. So the moon would be a good thing to look at tonight. But the clear dark sky chart. So I pulled this down last night. The forecast is there's about 30 different forecasts for the Bay Area. There's about 750 across North America. They do a lot in different regions, partly because of microclimates. So in the Bay Area, the microclimates are pretty particular. It can be really bad in in Morgan Hill and great in Gilroy, and then really bad again in Saratoga, and really good in San Jose. So we have a lot of different local forecasts in the Bay Area, so it's worth finding the one that's closest to you. So what is there to see? The stuff we're going to talk about in the second half of the talk is the stuff that I'm interested in. So, but I mean, the universe starts right outside your door, right? The sky is about 50 feet thick, or the atmosphere is about 50 feet thick. You can drive there in an hour. You can run there in a few hours. There's, once you get outside of that, there's all kinds of stuff to see. So let's talk about what there is. And it helps to have a little bit of vocabulary here. Near to Earth, we have satellites that are visible. You can get apps that show you when the ISS rises, for example. We have meteor showers that happen on a regular basis. Meteor showers are really just patches of gravel that are in the Earth's orbit that the Earth moves through as it moves around the sun. and this gravel's just minding its own business there when the Earth happens to swing through. So we're constantly in the process of going through meteor showers. Within the solar system itself, we have the moon. There's tons of interesting stuff to see on the moon. We have the planets. We have the sun itself. If you're a solar astronomer, you don't even need to stay up late like all the other astronomers. You can get up like normal people and look at the thing that you're interested in right out in the middle of the day. We have comets as well. There's a couple of interesting comets that are starting to brighten up that may put on a show this summer for us, which would be cool. We haven't really had a bright comet for maybe like 3 years now or 4 years, one that was actually visible in kind of amateur instruments. And there's asteroids. Asteroids are always flying by Earth or out there on their own. And there's a lot of people that are really interested in asteroids. Within our galaxy, we have star clusters, which come in open star clusters, the open variety and the globular variety. And we'll talk about a globular tonight. An open star cluster is a more loosely compacted set of stars. So in a globular cluster, you might have 100,000. Within an open cluster, you might have 100. And the open cluster is just generally more spread out than the globular cluster. We have nebula, which come in a whole variety of a whole bunch of types. Nebula are gas and dust clouds, some of them the remnants of stars that have exploded, some of them nurseries for stars or breeding grounds for stars or places where stars are forming. We have variable stars, including binary stars. So for many years when I was a child, long time ago in the last century, astronomers knew that there were tons of variable stars out there. These are stars whose magnitude changes over time. So they might go from magnitude 1, which is relatively bright, to magnitude 4, for example, which is relatively dim. And that might happen over the course of a couple days, or it might happen over the course of a couple months, or even longer. And for the longest time, nobody really knew what was behind variable stars. There were all sorts of theories about maybe changes in the way that the fusion core of the star itself was changing, right? So it was producing less energy. What we now know is that many variable stars are variable because of exoplanetary systems, because they have planets orbiting them. And some variable stars are variable because they're binary or even in trinary systems where the output of the solar system itself, the energy output of the solar system varies depending on which star happens to be the one that's in our line of sight. But then sometimes those solar system, the output of those systems varies because there are giant planets in the way, right? Or very large clouds of gas and dust that are in the process of forming planets. And that's a relatively new discovery. That's really only been in the last, I would say, 15 years or so. The exoplanetary systems are probably not more than 20 or 25 years old in general, but what we now know is there's all these exoplanetary systems all over the place, and amateur astronomers are beginning to understand how those, are beginning to see those exoplanetary systems. We also have nova and supernova. So nova are stars that explode on a fairly frequent basis. They're kinds of variables, but they explode they change their brightness in much more dramatic ways. And then supernova, of course, are just giant stars that go kablooey. And there's speculation that the star Betelgeuse in Orion may go supernova, or maybe in the process of changing itself fairly dramatically. And they tend to happen, every 100 years or so, supernova in our galaxy, at least from where we're standing. And then we have extragalactic objects. So extragalactic objects, we just straight up galaxies. And then we have clusters of galaxies, and those clusters themselves interact in pretty dramatic ways. Sometimes they're in the process of ripping themselves apart, or they're colliding, or exploding, or doing all kinds of cool stuff. So what are we going to talk about this month? We're going to talk about the constellations Ursa Major, Canis Venatici, or Canis Venatici, and the two constellations, Crater and Corvus. We'll talk a little bit about the moon. We'll talk about the three cool planets, Jupiter, Mars, and Saturn. And we'll talk about some deep sky objects, so a globular cluster and a galaxy. So Ursa Major. Ursa Major is the Big Dipper. It's actually a very large constellation called the Big Dipper is only part of it. Only about a third of the space of the sky in Ursa Major is the Big Dipper. It covers a wide range of space. It's about, what is that? Close to 40 degrees, right? From north to south, and about 10, 20, 30, 40, 50, almost 60 degrees from east to west. So it's one of the larger constellations in the sky. This pattern itself, so when we talk about this pattern, this is the region, right? So this whole region of space is labeled as a bear by a lot of different kinds of constellations. So as far south as Israel, Palestine, the Middle East, the Greeks, as far north as the Finns, in between with the Iroquois, they all named this space in the sky the Big Bear, which is kind of an interesting cross-cultural pattern, but easy to find because of the Big Dipper. So lots of galaxies in here. This area in here, particularly where you see all these red dots, these are all galaxies. This is the core part of the skylight super constellation over in here. The next constellation is Canes Venatici. Canes Venatici, my Italian is terrible, so pardon me. This is a very small constellation between Boötes, the herder or the shepherd, and Ursa Major over here. So this star here is Arcturus. And how do we get to Arcturus? Type it into the chat window if you know how to get to Arcturus. All right, so we're going to arc to Arcturus, right? So we arc to Arcturus to get through the handle of the Big Dipper to get to Arcturus. Canes Venatici is in between Ursa Major and Boötes. Now, what's interesting about this? So these are all little galaxies in here, or not little, but these little dots here are galaxies with like 50 to, a trillion solar mass space. But this area is really rich in here. There's a lot of cool stuff to see. A lot of our local supercluster of galaxies we're part of this local supercluster in here. This whole thing, this constellation, Canes Venatici means hunting dogs. It's not clear why. A lot of these constellations were named by Europeans in like this, the 17th, 18th centuries. So it sort of was the Northern Italians got a chance to name the constellations before a lot of the rest of us did. That's why this is called the hunting dogs. So that's Canes Venatici. Crater. So Crater is this relatively faint constellation. I say here that it's barely visible in San Jose. That's a little unfair. It's actually, once you kind of see Crater and Corvus, it's hard to unsee them. They're right kind of low on the horizon right now. Sort of like if you look towards Mount Umunhum, the box, right? The mountain with the big square box on top, the old radar station. So if you kind of look a little bit to the east of that, once the sun sets, you'll see Corvus much easier than Crater. Crater itself, the story behind Crater is that it was a cup, and it insulted the god Apollo somehow, and so it got tossed up into the sky. Corvus, the crow, is a constellation just south of the ecliptic. So the ecliptic is the path the sun follows through the sky. This constellation can be found from Spica. So when you arc through Arcturus, if you keep going, you get to Spica. And if you keep going through Spica, you get to Corvus. This is the southern boundary. This constellation is the southern boundary of our galactic supercluster. So roughly from here, if you kind of move from Corvus up around to the North Pole, off screen, way up over here, in that area in the skyline, that's our galactic supercluster. That's our local space. So much closer to home, the moon. The moon is an interesting object in its own right. So there's tons of interesting things you can spot on the moon. There are very straight, narrow canyons. There's a lot of craters within craters within craters, all that kind of cool stuff. The moon is the second brightest object in the sky, so you want to try to avoid looking directly at the full moon if you can. You want to use the terminator of the moon, particularly if you're looking with binoculars. So the terminator is this line of dark and shadow that moves across the surface of the moon over the course of the month. This shadow here will allow you to start to see details that'll get washed out in the full moon. So, for example, there's a lot of artists, some really cool artists who will sketch craters off the moon. They'll do that using the terminator, right? So they will pick a spot on the terminator and sketch that. You can also lower the brightness of the moon using a polarizing or a moon or a blue filter on your telescope's eyepiece. Obviously, those filters are a little more expensive if you've got binoculars because you have to double them up. So another thing you can do is increase, if you've got a telescope, is increase your magnification fairly dramatically. But generally, if you've got binoculars, the best thing to do is to just sort of look at the terminator, look along the terminator. So planets. Planets are found along the ecliptic. The ecliptic I mentioned just a little earlier. That's the path that the sun and the zodiacal constellations appear to follow through the sky. So there's a fairly straightforward reason why the sun, why these planets all seem to be within roughly the same area of the sky as the sun, and that's because as the planets orbit around the sun, they orbit in a kind of a reasonably flat donut-shaped space around the sun. That's the ecliptic. That was how planets were found over the course of history. Is that the planets appear to be stars that move over the course of time, and they move in this fairly narrow band of the sky. So they live in the constellation Taurus, for example. So right now Venus is in Taurus. Saturn and Jupiter are on the border of Sagittarius. Jupiter's still in Sagittarius, Saturn's in Capricornus, Mars is thoroughly in Capricornus. You can see here we have the first quarter, really the first quarter moon is on May 3rd, so tomorrow night, Sunday night. And we had our new moon last weekend on the 26th of April. So this is a cool graphic put out by the guy at glyphweb.com. Why is it cool? Well, because it tells you where the planets are in relationship to the sun in a fairly straightforward way. So this tells us that Saturn, Jupiter, and Mars are all in the morning part of the sky. This is full night. This is the evening part of the sky, and then this is sunset. So right at the moment, the only planet that's really visible at sunset is Venus. Venus isn't particularly interesting as a planet to look at. So Venus is covered in sulfuric acid. There's dense clouds of sulfuric acid in the atmosphere of Venus, and so the most we really see from Venus is phases. Venus will go through phases like the moon does, like our moon does. But you can't see anything under those clouds of sulfuric acid. So Venus is very bright right now. It's actually very close to the Pleiades, which are this very cool little object that kind of smudgy open cluster that you can see in the western horizon. And Venus is in the process of setting. So Saturn, Jupiter, and Mars are all visible in the morning. So Jupiter, right now it's at magnitude -2.3. It rises at 1 a.m. in Eastern Sagittarius. So this is good. We haven't been able to see Jupiter since last summer. As the year progresses, Jupiter will rise earlier and earlier, and then my guess is, I mean, because it's in Eastern Sagittarius, we'll be able to see it in the evening sky for sure in June, but probably starting end of May, yeah, maybe middle of June. So with Jupiter, the 4 main moons are very easy to spot with binoculars. They will generally be laid out across in a sort of in a line across Jupiter. With a telescope, it's fairly easy to make out the 3 cloud bands, the 3 main cloud bands. So this one, and this one down here. You can find all sorts of schedules for the location of the Great Red Spot. So the Great Red Spot circles around Jupiter. This storm down here in the corner. This storm has shrunk over the course of the last 300 years. So this is this very famous spot was originally seen by Galileo. It was one of his charges of heresy was that he had accused the king of the planets of having acne. But that storm has been shrinking dramatically over the course of the last 100 years or so. So you should see it now, and then you can tell your kids about it if it ever disappears. You can also find schedules for the location of the moons. So the moons themselves, as they orbit around the planet, they'll be visible at various times. One of the cool things that you can do if you have a reasonably large telescope is actually start to, is watch for those moon transits across the surface of Jupiter. And they move very slow, obviously, so it can be hours. But Jupiter's well worth a look. If you get a chance, if you're at a star party, if you even just in the backyard with binoculars, you'll be able to make out the disk. You'll be able to make out the moons. It's really kind of heartening to think there's things out there completely ignoring us, but still very beautiful. Saturn is, many people on their first view of Saturn is close to a religious experience. So Saturn right now is magnitude 0.5 in Eastern Sagittarius. Again, it rises at 1 a.m. It's about 2 degrees from Jupiter. So we remember how to make 2 degrees, right? We hold our arm up. Our little finger is 1 degree, right? So we need 2 of those. Saturn's moons are relatively easy to spot, but they're more spread out than Jupiter. If you can see this line here, this break between the inner and the outer rings, that's called the Cassini division. If you can see that, then you have a sign, it's a sign of fairly good seeing. The rings will change aspect over time. So as, over the course of 17 years or so, these rings shift until they're edge on. So again, this is one of these things where right now we're in a fairly good aspect for Saturn, but in 8 years or so, people may look at Saturn and not see much of the rings. So there's always a good idea to take advantage of that.
Hey, we had a question about the cloud bands on Jupiter. What is the minimum level of magnification necessary to see the cloud bands?
So I would say magnification isn't, I would say you probably need, I'd say in San Jose, a 6-inch telescope will get you, 6-inch telescope with a 6-inch Dob with like maybe 80 magnification will get you 80 power. But yeah, if you get a 6-inch telescope with a 25 or 30 millimeter eyepiece, you should be able to see cloud bands in Jupiter. Now, you're not going to see the tendrils, right? So, this is a very expensive photograph from the standpoint of scientific instruments. To get to the point where you can see cloud tendrils, you're going to need a pretty large telescope to see that. But with a 6-inch telescope, being able to see the bands won't be that hard. Okay, final planet, Mars. So Mars is magnitude 0.2 in Aquarius. It's about 25 degrees east of Jupiter. So remember how to make 25 degrees. That's the surf sign, right? I have never had a lot of luck seeing Mars in San Jose. I often end up with very bubbly seeing. I've looked through other people's telescopes and the views have been sharp. And occasionally I get sharp views as well. But Mars has seemingly less detail than either Jupiter or Saturn, although that's not really true. It's just different, different looking planet. So generally, you can see the polar caps. I've seen the polar caps a couple of times. Right, these are going to be white spots. These will grow and shrink over the course of the year. You can see often the Maria, so these dark areas, lava flows, or whatever they are, and then occasionally storms. So areas of the disk will get blotted out, will be a sort of a dusty red. You'll see Maria and then a dusty red patch on top of it. If you have a telescope, red or yellow filters will work better to be able to pull out vision or to be able to pull out features. In binoculars, it's not much more than a red blob. So still worth a look. Again, I think, every time I get a chance to look, I look at all the planets that I can. So that's Mars. All right, so let's talk about some deep sky objects. Globular cluster. So the first globular cluster we're going to look at is called M3. M3 is really, really easy to find. So you've got the Big Dipper up here, and you arc through the handle of the Big Dipper to Arcturus. And then hanging off the end of the handle of the Big Dipper is kind of this ball called Cor Caroli. That's in Cans Venatici, right? So this is the Cans Venatici constellation space over here. And this is the two main stars, Cor Caroli Alpha and Beta. Cor Caroli is the heart of Charles. It was named after an English king by an English astronomer, or by a German astronomer anyway. But Cor Caroli is a really cool little double star that's fairly easy to split in binoculars. But in between, roughly 2/3 of the way between Arcturus and Cor Caroli is M3, is this little globular cluster M3. So it's called M3 because it's the third object in the Messier catalog. The Messier catalog is a list of most of the beautiful objects in the Northern Hemisphere. It was put together by Charles Messier, who was a comet hunter in 18th century France. And Messier would go out and look for comets, right, in the middle of the night, and he'd see something smudgy, and he'd write it down on his star chart, and he would get up the next day at noon away with all his other astronomer buddies, and he would go for coffee, and he would say, I found this amazing thing. And the astronomers would say, well, no, wait a minute, that's not, Joe found that or Jacques found that like 6 years ago. That's not new. That's not a comet. So Messier got irritated by this. He started writing these things down, putting them onto star charts. This was the third object in the Messier catalog. It's actually the first one Messier discovered on his own. And there are about 110 of there are 110 of these. Messier found 105. And his friends added 5 more after he died. And they are like I said, they're most of the beautiful objects in the Northern Hemisphere. I think that the easiest way to find your way around the sky, or to figure out your way around the sky, is to learn how to find the Messier objects. They'll teach you to star hop. They'll teach you to see, right, how to understand what you're looking at. And so it's very much worth your time taking a look through the Messier catalog. So this is the globular cluster itself. So globular cluster is a very, very dense compaction of stars. This one in particular is about 500,000 stars packed into an area of about 100 light years. So this is immensely dense, an immensely dense collection of stars. It's also about 11 billion years old. So in many ways, it's as old as our galaxy is. And one of the more popular modern theories of globular clusters is that they are other galaxies, small dwarf galaxies that generally orbit larger galaxies like our own, that have been sucked in and compacted into these very tight clusters. Now, just as a kind of a measure of the density here, we have roughly 10 stars within 10 light years of us. and maybe another 10 stars within 50 light years of us. And there are really only, 400, 500, 1,000 stars visible in our night sky in any given night, right? If the closest star to us is 4 light years away, within this space, in this globular cluster, there would be the equivalent of 10,000 stars. So more stars visible within 4 light years in this globular cluster than are visible in our entire night sky. So obviously it's very likely that astronomy isn't really even possible at the center of one of these globular clusters, because you wouldn't be able to see outside of the cluster. It's unlikely that there are even any habitable planets in a place like this, but if there were, they would be unaware of what was happening outside of the cluster, largely because they'd be worried about what's happening on the inside of the cluster. So 2 galaxies, I mentioned these earlier, 2 very cool galaxies in Ursa Major. These are both also Messier galaxies, M81 and M82. They're also known as Bode's Nebula. They're 10 degrees from Dubhe, as you can see, right? We know how to make 10 degrees because we go out and we make a fist, right? We push it as far out of at the end of our arm as we can. That gets us 10 degrees. These galaxies are connected to each other. They appear to be gravitationally connected to each other. They're about 11 to 12, between 11 and 12 million light years away. And they're part of our local galactic cluster. So the Ursa Major galactic cluster is the galactic cluster that our local group is part of. Our local group consists of 3 galaxies, including our own. And these 2 galaxies are part of that local galactic cluster. So our local galaxies are all within about 3 million light years of each other, 2.5 million light years. These guys are the neighbors. These are the closest neighbors after our own galaxy. So on the right here, we have a long exposure photograph of these 2 galaxies. M81 on the left, which is kind of this classic grand design spiral, right? You can see the arms there, very pretty. And then on the right, we have M82, also called the Cigar Nebula. You can see that those red spots in there. That appears to be some interaction. If you look, other long exposure photographs here have shown that there's this kind of debris field in between these 2 galaxies. So it looks like they've run into each other recently. So it's possible that we're looking at something like a car accident on the 101, right? And there's like a fender over here and a galactic taillight over there. On the left, though, so the human eye isn't really designed to do long exposure photography. Our eyes are designed to be able to see stuff in the grass, right? Lions and gazelles. So we don't collect light, we don't keep it. But if you look here in the middle of this screen, you'll see these 2 smudges. So there's M82 here, and then there's M81. Now this sketch, so this is a sketch. And I like to show sketches because they're much more similar to what people are seeing through telescopes or binoculars. And what this sketch, what's cool about this sketch is it was done through 8x56 binoculars. So these are not large binoculars. 8 power, that's the magnification on the binoculars. That's 8 times, right? So 56 millimeters is the size of the objective, and the magnification is only 8x. It's obviously a very clear night, but this person was able to sketch these 2 very faint objects. Now, lots of times when I do this talk, and obviously we won't be doing that tonight, but we do a talk and then we go out to a star party afterwards, and people are a little let down by the fact that this whole thing just looks like smudges. The thing to keep in mind is that these smudges are 11 million years old, and you'll see them in the eyepiece. You may have to move your eyes around to be able to spot them, but you'll see them in the eyepiece. And they are breathtaking, partly because they're so old and partly because they're so big. But it really is something. So it's a smudge on this, but keep in mind that this is this is a fairly it's a fairly dramatic experience. So one more galaxy, M94, is an easy to find galaxy in Cans Venatici. This galaxy is 16 million light years away, so about 4 million more light years away than Bode's Nebula, than M81 and M82. Obviously, M94 is also a Messier object. But this one is on the boundary of, it's on the other side of our, on the outer edge past the boundary of our galactic cluster in its own cluster. So it's its own little local galactic cluster. So you might think of it as being in a separate state, right? So if M81 and M82 are in California, then M94 is in Nevada. But that state itself, that galactic cluster, is part of a larger supercluster of galaxies called the Virgo supercluster. There's a strange problem that astronomers have. They will find, they will name something a cluster, right? And then something bigger comes along. They discover something a little bit bigger, so they call it a supercluster. And then they discover that actually that supercluster is part of a larger supercluster. And they've already run out of adjectives because it's called supercluster, right? So it's very much like it requires a more precise set of terms, because you can't just sort of say supercluster or supercluster or mega cluster. But anyways, the Virgo supercluster is a giant collection of galaxies that our local galactic cluster is also a part of. So M94 is cool because it has this ring. And ringed galaxies are not, they're not as common as the other varieties of galaxies. They appear to be a variety of spiral galaxies, but not every galaxy that we see has rings. They're not particularly common. So this ring is actually visible even in your backyard in San Jose with a 6-inch telescope. On a cool night or a good night, you'll be able to see at least a bit of a ring. This is a sketch done with an 8-inch Dobsonian, sort of with average seeing. So this is the kind of telescope that the club will lend you for free if you're a member. We have a few other telescopes as well. But so that's M94. Very, very pretty telescope and relatively easy to see. So I was going to mention how to find it. So if you find Corcaroli, right, that's the ball that's hanging off the end of the arm of the Big Dipper, then there's Beta Caroli is the other star on the other side of the constellation. And then M94 is really just sort of halfway in between there. So if you can find Corcaroli with your binoculars and you can find Beta, you may be able to see M94 in there. It's about magnitude 8.5. It's not super bright. You're going to need a clear night to see it. I wouldn't try it tonight because I think the sky's not particularly good, but it's a pretty easy one to find. All right, so what can you do on a cloudy night when you can't see anything after dark? So you can plan your next observing session. You can go to zooniverse.org and help classify features on Mars or galaxies or identify black holes. So Zooniverse is a crowdsourced science site that for many years has allowed postdocs and various other kinds of researchers to ask the public to contribute to scientific projects. One of the easiest and one of the first projects that they did was, so we have billions of pictures of galaxies that nobody's ever looked at. As far as we can tell, based on the 100 years or so that we've been looking at galaxies, there's only really 5 types. Only really 5 types of galaxies. And that seems really remarkable. If we've only been looking for 100 years and we've only found 5 types, that would be pretty phenomenal. So one of the things that the Zooniverse Galaxy Identification Project does is it shows the public a picture of a galaxy and it asks them to classify it. And it'll show the same picture to 100 people and ask those people to classify it. And then the postdoc is able to apply, or the program people are able to apply some kind of basic statistics to try to determine whether people are classifying the galaxy into one of those 5 basic types, or they're seeing something brand new, right? So are they seeing a kind of galaxy that nobody's ever seen before? And so far, I haven't heard anything. It seems like all the galaxies we see are still one of those 5 types. But that's the kind of project that's available on Zooniverse. It's a good way to kind of spend some relatively productive time in the afternoon if you've got nothing to do. The third thing, so Glenn Newell, who is our guy in the chair, Glenn Newell has a bunch of astrophotography tutorials on YouTube. You can take a search for Glenn's tutorials on Glenn. You just search YouTube for Glenn Newell Astro Imaging. All right, so a little bit about the SJAA. We were founded in 1954. We do events for the public and events for club members only. And public events are usually at the clubhouse or will be online. And all public events are listed on the SJAA website, and we also use Meetup for a fair number of our events, and that's probably how a lot of you came to us. Club events are online, the clubhouse, and various dark sky sites in the South Bay and the Salinas Valley. Public events are free. Obviously, all of this stuff is up in the air right now, but we do, generally we do Starry Night Star Parties at Rancho Cañada del Oro, sponsored by the Santa Clara County Open Space Authority. That's once a month. We do solar observing at Hoogie Park, and the guy who does the solar observing program, Wolf, is on this call tonight. We're trying to figure out how to get solar observing into some kind of online state so people can come to a solar observing event from the comfort of their own home. We do the introduction of the night sky talks like the one you're in right now. We do more in-depth talks as well as guest speakers. We do the in-town star party at Hoogie Park, which is generally the same night as our intro talks, so that's first and last quarter moons. Again, this is one of these things that we want to try to figure out over the course of the next couple weeks, is how to run star parties for the public, obviously without having to have people come down and stand less than 6 feet apart from each other. We do fix-it sessions to help with new or mysterious or broken equipment, and we do school star parties throughout the school year as well. Club events, so membership includes a telescope loaner program, so we have a variety of telescopes of various sizes, small to large. We'll loan you the telescope for 2 full new moons or 2 months, and there's no cost. We have a quick start instructional program, which is a more in-depth program than our fix-it programs. We have membership. So membership in the club includes membership in the imaging special interest group, which is run by Glenn and Bruce. We have exclusive Bay Area dark sky sites and star parties. We have a library you can borrow books from, and we have discounts at Orion Telescopes in Cupertino. Orion is based in Watsonville. We're very lucky to have a store in Cupertino. I just recently ordered something from Orion on like Wednesday and got it today. So they're still shipping stuff. There are more telescope stores in Canada than there are in the United States. And we're so lucky to have a store in Cupertino. So they make good telescopes. I have one of them. They're worth your time, and they won't try to sell you more telescope than you need. So, and membership's only $20 a year. So, back in pre-pandemic times, it wouldn't be unusual for me to spend $20 a week on coffee. So $20 a year as a membership is really pretty good. All right, any questions?
People saying thanks for a great presentation. And some of us have been answering some of the questions in the chat as you've been talking.
Cool.
Marion reminding folks that we have a quarterly newsletter that's part of the club benefits.
Okay.
No questions yet, but yeah, a lot of thanks and great. And people are sharing the link for watching later as well.
Okay, cool.
Yeah.
All right. Well, thank you everybody for coming out.
Oh,
And
yeah, we'll let Wolf offer. There's a question about sunspots. We'll let Wolf is the solar expert. You're gonna have to
okay.
wait a while for that. We'll let him answer in the chat. Uh, yeah. Okay.
All right. Thank you everybody for showing up.
Thanks all, and we'll stop the stream now, and we'll see y'all next time.
Okay. Thank you, Glenn.
Yep. Thanks.
All right. Let me, where's the meetup here?